Hello students, today I'm going to give you a brief introduction to the data booklets, but before that I will show you where you can obtain the soft copy of the data booklets from. You can go to Google and then you search the Singapore Examination and Assessment Board, in short SEAB. Yeah, if not you can just type directly seab.gov.sg and then it will bring you to this particular page. Okay, and then if you scroll down a little bit, you will get to see the different examination levels. So you can click A levels, and it will bring you to this particular page, which shows you the examination timetable for 2021. Yeah, so if it's next year, then you will get to see the examination timetable for 2022. Then there will be some information like on school candidates, some of the important stuff like registration information, exam rules. They are important for you when you're sitting for the A levels, but today we are not talking about assessment rules or examination rules. We are talking about where you can find your data booklets and the syllabus documents. So if you are sitting for the exam in 2023, you will get to see this updated at the end of 2022. Okay, so for now, I'm just going to click exam syllabuses examining in 2022. So it will bring you to this particular page. You can look at the Cambridge subjects and you can just look through them. So there will be two columns here, subject codes H1 and H2. If you are familiar with chemistry syllabus is 9729. So 8873 is H1. So you need to go to the right place to click on the correct syllabus document. So over here is chemistry, English, H2 9729. So you can just click on it and then it will bring you to a PDF document where you can download the document and save it either in your computer or in your phone. Okay, yeah. Then I will just go straight to the data booklet. So this is what you're going to get. This is not the actual data booklet. This is what we call the syllabus documents together with the data booklet. The data booklet is actually found right at the end. So let me just bring you there. Yeah, so over here you can see data booklet for chemistry, advanced syllabus. Yeah, then just take note on some of these things for use from 2017 in all papers except practical exams. So do take note that for practical exams, you will not be allowed to bring in your data booklets and you will not be given the data booklets. For practical exams, you will only be given the last 2 pages, which is from section 9 onwards. So under the qualitative analysis notes, okay, and then all the way to reaction of anions and test for gases and color of halogens. Yeah, so you will only be given these 2 pages. So section 9 for your practical exam. It will be printed for you in your examination booklets. So it's paper 4 practical exam. So it will be printed the last 2 pages. Okay, so in case you are curious about the syllabus which you are going to sit for, you can just download this document and look through everything. Yeah, it gives you a lot of details on the H2 curriculum, such as the curriculum framework, assessment objective, blah blah blah. You can look through them, and when you go straight into the syllabus, for example, okay, over here you can also look at the scheme of assessment. So this will be more important when you're in JC2 because you need to know what you're sitting for your A levels. So for H2 chemistry syllabus 9729, there are a total of 4 papers. Paper 1 is MCQ, paper 2 structured questions, include database questions, paper 3 free response questions, and paper 4 will be practical. So you will sit for practical exam first. That will usually take place around the middle of October, and then your main papers will be sometime in November. Okay, these details are not so important for you right now if you're in JC1 because you do not need to worry about them. Usually for school-based assessments, for example, promotional exams or common tests, block tests, you will only be tested, you will not be tested all 4 papers, maybe just 1 or 2 papers, so you don't really need to worry about them. Okay, so this is a very beautifully illustrated content maps. If you want to, you can take a look at it. Okay, if you are interested in the syllabus, the exact learning objective of your syllabus, you can look at page 11 onwards. Okay, so they showcase to you every single learning objective you need to learn for your exams. So for example, in the first topic, atomic structure, if you look at 1A, yeah, so it reads candidates should be able to identify, describe protons, neutrons, electrons in terms of their relative charges and relative masses. Yeah, so in the structure of your notes, the information will be found somewhere inside. So you need to at least be clear about what you need to know for your syllabus. Okay, again, the presentation today is not about talking about your syllabus. Okay, it's more pertaining to what you can expect from the data booklet for those of you who are new. So we will jump straight into the data booklets. Yeah, so you would have received a copy of the data booklets either from the photocopy shop or from your teachers, or if not, you can download a copy online. Okay, so you'll be excellent or very important, very informative if you understand what informations are present in a data booklet and what information are not present in data booklet. Because some of the students go for exams without knowing what are the information present, and then they get panic along the way. Okay, so I hope this video is useful for you. At least you get to know what are the information present, and any additional information which is required of you will be given to you in the preamble or in the stem of the question. Okay, so there are a total of 10 sections here. So we have section 1, which provides you with the important constants, standards. Okay, so you will need this page once in a while. And then especially if you're in JC1, 2 and 3 will be very important, because ionization energies is what you will encounter in atomic structure. Okay, so do take note of the units as well. It's in kilojoules per mole. Section 3 and 5, these are bond energies and ionic radii. Very important when you're learning chemical bonding. Okay, so you will find some of these data informative. You might need them in your tutorials, in your exam questions. Okay, the fourth one, which is on standard reduction potential and redox potential, you will use them more in JC2. Okay, after you have learned electrochem. Okay, but for most of the JC1 topic, you will not need to use 4 except for redox, when you need to balance redox equations. Yeah, so not only do they contain the standard reduction potential, they also contain the relevant half equations which you will need for your redox balancing. So any of the redox equations which you have not encountered before, they will be given to you in the stem of the questions. Okay, 6 and 7 typically will be used in H3, so you will not need them in H2 exams. So these two will be for H3. Yeah, so they are the lifesavers for H3 students. I will not attempt to explain what they are. Yeah, but we do see some of the schools prelim exams. In fact, even for H1 A-level paper, they do ask the students to pick up some data from section 6 and 7. So do not be too alarmed if in a normal H2 exam you are asked to use information from 6 and 7. But other than that, they are largely for H3 exams. So do take note of that. Okay. For 8, you will use them for the topic on arenes. Okay, it's one of the topic which you're going to learn in organic chemistry. Okay, it showcases to you the orientating effect of the groups in electrophilic aromatic substitution. Okay, and if you recall what I mentioned earlier on, 9 will be given to you as well. And that is the only 2 pages given to you for a practical exam. So these are what we call qualitative analysis notes, so that you don't have to memorize all the color of the cations because they will be given to you. And then number 10 will be familiar to you if you come from secondary school or O levels. It's a periodic table. But please take note that the periodic table in A level is given to 1 decimal place. Okay, yeah. So yeah, I'll just run you through. Okay, so these are the important values, constant standards. Okay, so for molar gas constant, you will learn it in gaseous states. You will use it pretty often in the topic under gaseous states. Yeah, so there may be other topics which you will need to use it, but it will be more rare, at least for H2. Faraday constant, you will learn it or you will use it more often in electrochem. And then Avogadro constant, I'm sure you know what it is from secondary school. Okay, yeah. And these two, or rather 1, 2, 3, 4, 5, 6. These 6 datas are often not used in H2 exams. Okay, quite rarely will the question ask you to use them, but I shouldn't say no, but I use the word rare. Okay, but do take note of their existence, because sometimes students forgot that they exist. Okay, the Planck constant and the speed of light in vacuum. Okay, under gaseous states, it's important for you to note this data, molar gas volume. Yeah, so 22.7 dm cube per mole at STP. STP, take note of how it's being defined. 10 to the power of 5 Pascal or 1 bar, 273 Kelvin. Okay, for room temperature and pressure, take note that it's defined as 1 atmospheric pressure or 101,325. Yes, you're required to know this number, 101,325. So please remember it, or I mean, don't have to remember it, but it's in your data booklets. Room temperature is defined as 293 Kelvin, not 298. Okay, so I'm going to write it here, not 298 Kelvin. Okay, so the definition has been updated. Ionic product of water, you will use it under the topic acid-base equilibrium. Okay, maybe not so often in JC1. Specific capacity of water, this is especially important in energetics. Okay, then the second section is on ionization energies. If you remember what I said earlier on, you are given the first 4 ionization energies of selected elements. Usually it's the first 30 elements. You will find them very useful in atomic structure. Yeah, so there isn't a need to memorize any of these values. You can just use your data booklet to flip and check these values out. Some of you might be asking, are you allowed to bring data booklet into exams? So a short answer is no, because the data booklet is provided for you during major exams. Major exam meaning common test, block test, promotional exams, prelim exams, and A levels. Yeah, for the small class tests or even like lecture tests, if there exists, there's lecture tests, then you might be allowed to bring your own data booklets. Okay, but in most cases, you are not allowed to bring your own data booklet for exams. Okay, yeah. Yeah, so this is for section 2. Section 3, boron energies. Yeah, so do take note of how the data are being arranged, because sometimes students panic a little bit. Yeah, so for the data on boron energies, they are arranged as number 1, diatomics. Diatomics meaning their exact values. How do you know their exact values? Well, because these are the actual boron energy of these elements or compounds. Okay, so these are exact values. So it splits between homonuclear meaning the same element. So for example, dioxygen, dinitrogen or deuterium. Okay, and heteronuclear, so like all the hydrogen halides. And take note that carbon monoxide is also given to you. C110 is 1077 kilojoules per mole. So this is given. A lot of students forgot its existence. Okay, if you move on to the next page, you are given the average values of boron energies in polyatomic molecules. So do be very careful how you go about using the values. Okay, so what do I mean by that? Like let's say for energetics, sometimes you are required to quotes the bond energy of dioxygen. That means OO double bond. So you're supposed to quote 496 kilojoules per mole. But many students, for some reasons, they went to quote this value, which is 150. Yeah, take note that 150 refers to the peroxy OO bond. This is known as a peroxy OO bond. Or at this stage, you can simply call it OO single bond. Yeah, and another values are often misquoted by students include the CC double bond with the CC partial double bond in benzene. Yeah, if you are talking about the CC double bond in benzene, you should be quoting 520. For a non-delocalized CC double bond, usually we are looking at 610. Okay, so just be very careful about them when you quote the data. Okay, and another common mistake students will make will be C double bond O. For ketone. Ketone meaning a compound that contains C double bond O and the carbon is bonded to two other carbon-based groups. Yeah, so that's 740. But the CO bond energy in CO2 is 805. So remember this. So this is the one that differs quite a bit from the data booklet in the old syllabus. Yeah, but of course, I'm not expecting you guys to know anything about the old syllabus, but just note that there is a bit of difference, like especially when you're doing the older syllabus examination questions. Sometimes you will see that the values are a bit off. Yeah, so that's because in the new H2 curriculum, 9729 syllabus, you are given the exact or rather the actual bond energy of the CO double bond in CO2. Okay, and it differs by quite a bit. So do take note of this. Okay, so the fourth section will be on standard electrode potential and redox potential. Basically, you will learn more about them in JC2 under the topic on electrochem. Yeah, so just take note that there are two columns. The first column shows you the reduction half equation. So under redox, you will learn this known as reduction half equation, where the species with the higher oxidation state is on the left, and then electrons being introduced, and then they get reduced to something else. Yeah, and these values are what we call standard electrode potential. They are measured against SHE, otherwise known as the standard hydrogen electrode. So by being the standard is given a default value of 0.00 volts. So in case you are wondering where to find it, it's actually over here. Yeah, so the standard hydrogen electrode is made up of hydrogen gas, a bubble into a 1 mole per dm cube concentration of H plus solutions. Okay, and the hydrogen gas is being maintained at 1 bar, and temperature is 298 Kelvin. Okay, so these things are mentioned over here. Yeah, so in case you are wondering, is there any use of this particular page? Actually, it spans over 4 to 5 pages. This page is important for JC1 when you are doing redox, especially the case when you need to balance redox equations. So for example, you need to balance the equation between the oxidation of iron 2 to iron 3 using potassium permanganate as the oxidizing agents. So what you need to do is you need to scroll through, not scroll through, but if you have a physical copy, you need to flip through, and then you need to find the correct equation. So in this case, permanganate, you know that you'll be reduced to Mn2 plus in acidic medium. Okay, and this is the first half equation you will choose, and then you will choose the half equation involving iron 2, iron 3. So this is another one which you will choose. Okay, but of course, because iron 2 is being oxidized, when you try to write out the oxidation half equation, you cannot write out this way. You have to write it as Fe2 plus, you get Fe3 plus electrons. Okay, in case you're a bit lost here, it's okay, because when you are learning the topic on redox, it will be taught to you in greater details. Yeah, and also take note that section 4 is divided into 2 portions. Okay, so the first portion showcase the reduction potential arranged in alphabetical order. Alphabetical order of the elements. So you start off silver. So it's based on the chemical symbol. So silver, although it's spelled with S, right? But it takes on its chemical symbol, which is argentum, Ag. Okay, so alphabetical order, it goes down. So A to Z. I think it's easier with most students. Okay, so most students actually found 4A to be more useful. Okay, so if you flip through to the last bit, you will notice that there is also a section 4b showcases the reduction potential in decreasing order of oxidizing power. Most students don't find this page very useful. Basically, this page is just to tell you that the strongest oxidizing agents amongst them is actually fluorine, followed by peroxy disulfate and then H2O2 MnO4 minus. Yeah, so in case you need to look for oxidizing agent, I think this page is useful, but the list is quite limited. They don't showcase or they don't provide you with all the oxidizing agents, just selected ones. So it may not be extremely useful, but if you find it useful as a quick look for the potential oxidizing agent, I think this page is fine. Okay, yeah, but other than that, you can make do with 4A. Okay, then section 5, as I mentioned, it's useful both in atomic structure and chemical bonding. Yeah, because they showcase to you a few things. Number one is the atomic radius. Okay, let's say for hydrogen, it's this. And then also the ionic radius, so hydride is a lot bigger. Then you notice that cations tends to be smaller than the atoms, and then anions tends to be bigger. Yeah, you will learn more in atomic structure. Okay, and also do take note of the difference, okay, in this case, between what we call the single covalent radii and the van der Waals radii. So van der Waals radii, it's okay. I think first it's easier to explain what exactly is a covalent radii, and you will get to listen to it in more details under the topic on chemical bonding. But basically, it's like the halfway mark between the length of the covalent bond and the nucleus of the atom. Okay, so that will be the so-called atomic radius. But some elements don't form compounds. For example, helium and neon. So what is more useful is perhaps known as the van der Waals radii, okay, or van der Waals radius. So it showcases the midpoint of the neon atom, for example, between the midpoint of another neon atom when it's in the gaseous phase, and that is where they exert van der Waals forces on one another. Okay, so that is the best proxy we can have when we measure the van der Waals radius. Okay, yeah, so that was also something which you can take back and then look at the information from the data booklet. Yeah, but I think one thing that sometimes students found a little bit confusing is that all the information are given in one page, although we are looking at different things. So you are given the cation and anionic radius, you are given metallic, covalent, and van der Waals. So do be very careful when you look at the relevant information. Do not be confused. Yeah, okay, so I think this spans a few pages, I think 2 to 3 pages. Okay, and then the next part over here is actually on nuclear magnetic resonance, so which I will not go into details. So if you are doing H3, section 6 may be important data for you to use. Okay, so I will just skip this. Section 7 is another data which in most cases is used in H3. Yeah, but there was a year where the H1 paper, the A-level paper, actually asked the students to quote a value from here. Quite surprising. Yeah, so these are the infrared absorptions frequency. Again, even if you're not taking H3 when you're in JC2, it doesn't really matter. If you're interested, you can read more about them. Okay, so I will not attempt to discuss too much. If you are interested, you can always find out the information. Okay, and then moving on to section 8. This again, I mentioned it will be a lot more useful if you have learned the topic on electrophilic aromatic substitution under arenes. Okay, then you will learn about the orientating effect of groups bonded to benzene. Okay, whether the groups are activating or deactivating. So again, I will not say more because you will encounter them in arenes. Okay, section 9, I have talked to you about it before. I mean earlier on. These are information you will find very useful in practical exams, and it will be given to you. So the whole of section 9, the 2 pages will be given to you. But you might be wondering, what about for H2 theory paper? Is it still useful? Maybe not so useful for one reason, because now the skills which we want to test you in identifying cations and ions, we would have tested you in your practicals. Okay, so these 2 pages might not be so useful, except, okay, please take note of this, except for section 9D. Yeah, do take note that the color of the halogens, be it chlorine, bromine, or iodine, right? The elemental color is a little bit different from their color in aqueous medium. Okay, and some of them will also be a little bit different in color in hexane. Hexane is a non-polar solvent. Okay, so this is a non-polar organic solvent. Basically, it has the formula C6H14. Okay, so do take note of it. Many students overlook this portion. Yeah, so if you overlook this portion, then I think it's high time for you to realize that it exists. Yeah, and especially the case for iodine. Okay, iodine aqueous is brown. When it's very diluted, it's yellow or pale yellow. But the color of iodine in hexane, a non-polar solvent, is purple. So there's a huge difference. Okay, so do take note of it. The last page is the periodic table. So it's a bit different from what you have in secondary school or O levels. Okay, maybe the first thing is maybe the way it's being written. Okay, you will notice that the atomic number is written on top. Okay, so this is atomic number. The symbol is given, and then the name, and then the relative atomic mass is given below, and it's given in 1 decimal place. Yeah, so in H2 Chem, you have to quote the relative atomic mass to 1 dp. Yeah, so do not remember values which you have remembered from secondary school. Okay, for example, like iron, I think in secondary school is 56, in A levels is 55.8. And then let's say for silicon is 28 in O levels, but 28.1 in A levels. Okay, so yeah, do take note of this. And this is the last page of your data booklet. Okay, so I hope you find the introductory video to your data booklet interesting and useful for your H2 studies. And do look out for more videos for H2 chemistry in time to come.